Welcome to the Two Beans in a Pod. Today, we're diving deep into, well, one of the most ambitious and frankly enduring mysteries in the history of science and engineering, Nikola Tesla's vision for global wireless power. This was famously embodied by the Wardenclyffe Tower. This monumental structure, its framework was finished around 1901 in Shoreham, New York, stood 187 feet tall, had this massive 55-ton conductive dome, and get this, a 120-foot iron root system digging deep into the earth. Tesla's incredibly bold aim was nothing less than to change the world forever by transmitting electricity without wires.
Right.
So our debate today really hinges on this core question. Was Tesla's grand vision for, ubiquitous wireless electricity a scientifically sound and practical endeavor that was perhaps ultimately suppressed by commercial interests? Or was it an ambitious but, let's face it, potentially inherently flawed concept with just insurmountable technical and practical limitations? I'll be arguing that Tesla's system was indeed feasible, certainly backed by his extensive experiments, and possibly thwarted by the prevailing economic structures of his time.
And I'm going to contend that despite Tesla's undeniable genius, nobody disputes that, his global wireless power system, especially at the scale he imagined with Wardenclyffe, faced really significant scientific and practical hurdles. Hurdles that I believe ultimately led to its demise, perhaps irrespective of those external commercial pressures you mentioned.
Well, Tesla's track record, I think, really speaks volumes about his capabilities here. I mean, his historical success with alternating current AC technology and his resounding victory over Edison in the Battle of Currents, that had firmly established him as America's greatest electrical engineer by 1900. He wasn't just some theorist locked away. He was a groundbreaking demonstrator. Think back to 1891, he captivated audiences wirelessly lighting gas discharge tubes right in front of the American Institute of Electrical Engineers. He was vividly showcasing his understanding of power transmission through the air. This wasn't just an abstract idea. He made it, a tangible reality.
Okay, fair point on the demonstrations.
And later at Colorado Springs, Tesla conducted even more groundbreaking experiments with this massive coil. He meticulously observed phenomena like lightning strikes and confirmed his words that the Earth itself could be used as an electrical conductor. And he also verified the conductivity of the ionosphere, that electrically charged layer way up in Earth's upper atmosphere. These empirical tests, they produced colossal bolts of electricity arcing hundreds of feet, even lit up light bulbs from afar. They unequivocally convinced him that his dream of worldwide wireless electricity was feasible. So his vision for Wardenclyffe, it was this global network of towers designed to sort of pump electricity into the planet, mingling with those natural telluric currents, the massive electrical currents flowing under the Earth's surface, and also sending energy skyward into the ionosphere. Customers, he imagined, would just tap into this world wireless system with really simple ground connections and spherical antennas, effectively receiving what would be, free electricity. And some modern calculations, interestingly, even suggest this could have been a superior alternative to the traditional costly grid systems we have today. From my perspective, the project's abandonment was largely, maybe primarily, due to financial interests. JP Morgan's investment just dried up, especially after Marconi, who, let's not forget, used 17 of Tesla's own patents, achieved his transatlantic telegraphy feat with a considerably less expensive apparatus. Tesla himself, he lamented that his revolutionary idea was, quote, hampered and ill-treated by want of means, by selfish interests, pedantry, stupidity, and ignorance.
Okay, well, I absolutely acknowledge Tesla's unparalleled genius in many areas, particularly AC, that's undeniable. His ambition for global wireless power at the scale he imagined, particularly with Wardenclyffe, it really does appear scientifically questionable and, I'd argue, practically unfeasible for his time. It's crucial to remember, despite all his work, Tesla's copious diaries, as noted by researchers, were often notoriously vague and lacking in technical details.
Which leaves a lot open to speculation, right? Rather than providing concrete, replicable designs for a truly global system. Now, our contemporary understanding of wireless power transfer, it kind of categorizes methods into, say, near field, like resonant inductive coupling, the stuff we use for charging toothbrushes or phones, short to mid-range, and then far field, or power beaming for longer distances using microwaves or lasers. The principle of evanescence, which is key here, where electromagnetic fields just rapidly lose strength the further they get from the source, well, it dictates that fields decay exponentially with distance. This makes worldwide transmission without truly immense, unavoidable energy loss seem highly improbable, at least under our current understanding of physics. Critics have pointed out that dispersing energy over the entire Earth and then trying to somehow refocus it effectively, well, it horrifically breaks the second law of thermodynamics. You just can't get more usable energy out than you put in, especially when it's spread so incredibly widely and inefficiently.
But the second law applies to closed systems. Wouldn't harnessing the Earth's resonance change that dynamic?
That's a complex question in itself. But moreover, Tesla himself, when discussing the project's end, he acknowledged it was only expensive. That implies significant financial and engineering hurdles that went beyond just external suppression. The commercial success of Marconi's much simpler telegraphy, it really highlighted the economic impracticality of Tesla's grander, frankly unproven schemes at that moment. And furthermore, even if such a system were technically possible, the environmental and health implications of essentially charging the atmosphere with millions of volts, they would have been severe and were completely unstudied. Concerns about significant effects on plant and animal life, potential gene warping, those were raised later. Even today, rigorous safety standards are absolutely necessary for any kind of significant power transmission through the environment.
Okay, to build on that, let's really dig into the mechanics Tesla himself described. He explicitly stated that Wardenclyffe was designed to shake the Earth, to get a grip on it, using the planet itself as an electrical conductor. The plan was to send energy into the ionosphere and into the Earth's crust simultaneously. His Colorado Springs experiments, they provided pretty robust empirical evidence for this theory, didn't they? He successfully illuminated bulbs from afar, and crucially, he recorded the Earth's resonance, demonstrating the existence of standing electromagnetic waves on the ground. This wasn't about just, blasting power into the air. It was about creating a resonant circuit with the planet itself. Modern resonant inductive coupling systems, a principle Tesla absolutely pioneered. They demonstrate that efficient power transfer over distances several times the coil diameter isn't just possible, it's actively being developed for things like charging electric vehicles right now. Some contemporary analyses of his work do support his contention that wireless power on a significant scale is not only feasible, but potentially superior to the vast, costly wired grids we rely on today, especially if you could minimize losses by keeping the Earth resonating at its fundamental frequency.
I understand the emphasis on Colorado Springs, advocate, I really do, but I'd offer maybe a slightly different take on their scope and how they truly translate to a global system. Yes, Tesla's Colorado Springs apparatus could generate immense voltages up to 3.5, maybe 4 megavolts, but in its design, it was what engineers call electrically very short. Think of it like a radio antenna that's just far too small for the wavelength it's trying to transmit. In this case, apparently only about 1% of the wavelength. Now, what this means, according to modern analysis, is that it fundamentally does not radiate space electromagnetic waves in the way you might typically imagine for broad atmospheric transmission. Its function seems to have been primarily through ground conduction or perhaps very limited near-field effects. So, extending that specific principle to a global scale, where one tower like Wardenclyffe pumps power across the entire Earth's surface for anyone anywhere to consume, that remains problematic without, appearing to violate fundamental energy conservation principles. The concept of free energy here, it's very appealing, but it often ignores the absolutely massive energy input required and the unavoidable losses inherent in any real-world system, especially one of this scale. Even with today's advanced understanding, achieving truly global, ubiquitous wireless power faces immense efficiency challenges that go far beyond the near-field effects possible today with resonant inductive coupling. This idea of resonating the whole Earth is fascinating, I grant you. But how do you practically envision harnessing that diffuse energy globally for widespread use without astronomical losses? Where's that grip on the Earth for millions of users?
That's a fair question on the practicalities of tapping in, but I would frame the core issue differently. I still believe the primary obstacle to Wardenclyffe's completion and the broader implementation of Tesla's vision wasn't some inherent technical impossibility, but rather the profound challenge it posed to the profit-driven energy model of the time. J.P. Morgan, Tesla's key financier, was quite explicitly interested in wireless telegraphy for communication, not in bankrolling a system that would effectively give away free electricity that, crucially, couldn't be metered.
Right, the metering issue is key.
Exactly. And the rapid success of Marconi's less ambitious transatlantic telegraphy, which, again, ironically, used 17 of Tesla's own patents, it undeniably made investors incredibly wary of Tesla's much grander and, yes, admittedly, expensive vision. If power could truly be tapped by anyone with a simple receiver, just as Tesla envisioned, it would fundamentally undermine the entire business model of existing and emerging power companies. This perspective strongly suggests, to me at least, that the project was hampered more by financial suppression and, frankly, self-serving interests, just as Tesla himself bitterly observed, rather than any fundamental scientific flaw in his underlying principles.
I hear your point about the sheer expense, but isn't it plausible that what was deemed expensive back in 1900, especially for such a disruptive, potentially unmeterable technology, might have been intentionally made to seem prohibitively expensive by those protecting their existing investments, rather than being inherently unfeasible from a purely engineering standpoint?
While financial motives are undoubtedly part of the complex story, I just find it difficult to accept that as the sole or even the primary reason for the project's ultimate failure. Tesla's own statement that the project was only expensive, it can't just be brushed aside. Projects of such an unprecedented scale and ambition, they would require immense, continuous investment, far beyond what Morgan initially provided, or indeed what any single financier would typically underwrite for such a revolutionary, unproven technology. Even if you grant it was technically feasible in isolated lab experiments, the sheer practicality of deploying and maintaining a truly global infrastructure and the, let's be honest, immense challenge of creating any kind of sustainable business model for effectively free electricity, these were enormous hurdles. Marconi's achievement, though less ambitious, was clearly commercially viable and had a direct path to market.
Tesla's plans, remember, weren't just for power. They also included these rather speculative, unproven capabilities like weather control and text-image relay. That likely contributed significantly to investor skepticism and the perceived risk. So I think it wasn't just corporate greed, though that might have played a part. It was also a lack of a clear, cost-effective, and immediately marketable path for an untested, absolutely monumental system. A system that promised perhaps too grand a revolution for its time and maybe too disruptive for any economic structure back then to readily support.
We're certainly delving deep into the complexities of Tesla's vision here. And if you're finding this discussion as illuminating as we are, please do remember to hit the like button and subscribe to the Two Beans in a Pod for more analyses like this one. Your support really helps us bring these fascinating conversations to life. Now, turning to the societal impact for a moment, the potential benefits of Tesla's system, if it worked, for humanity were just revolutionary, truly far-reaching. Imagine a world where all electrical devices, phones, cars, everything, are powered without wires. That would dramatically reduce the need for traditional, centralized power grids and, importantly, the associated carbon emissions from generating that power.
A powerful image, certainly.
Tesla's vision offered a potential path to universal access to energy, possibly solving significant global energy challenges and drastically reducing our reliance on fossil fuels. Now, while concerns about electromagnetic field or EMF exposure exist, and they're valid to discuss, some studies have debunked the myth of widespread harm from typical electrical sources we encounter daily. Plus, Tesla's system wasn't just about indiscriminately, charging the atmosphere. It was conceived as a more sophisticated approach designed for efficient utilization of natural earth currents and resonant energy transfer. The societal impact of readily available, ubiquitous energy could have been utterly transformative, lifting communities out of energy poverty,
fostering unprecedented technological advancement. It's truly breathtaking to consider the sheer audacity of Tesla's vision, isn't it? I mean, to even conceive of shaking the Earth itself to use it as a conductor.
Absolutely. Even if, as I argue, it was ultimately flawed, the sheer scope of that ambition is undeniable, a testament to his unique genius. However, while those are compelling arguments for the potential benefits, have you really considered the serious and back then largely unaddressed potential hidden costs and risks? Pumping millions of volts of electricity into the Earth and atmosphere, as Tesla's system might have effectively done, it raises very serious environmental and health concerns. Concerns that were barely understood in his era and frankly remain significant even today. Even if some low-level EMF myths are, let's say, debunked for everyday exposure, the sheer scale and power density of Tesla's proposed global system could plausibly have had significant effects on plant and animal life.
There were, and still are, underlying fears about things like gene warping or the long-term effects of chronic high-level microwave radiation exposure. Although his system wasn't microwave-based, the principle of saturating the environment is similar. Countries like Sweden, for instance, have implemented precautions for EMF exposure based on ongoing studies, even for much lower levels than what Tesla might have generated globally. Furthermore, think about the sheer waste of energy if the system weren't perfectly efficient, which, let's be realistic, it almost certainly wouldn't be, potentially defying the second law of thermodynamics on a global scale in terms of useful work extracted versus energy input. That inefficiency alone could be environmentally disastrous. So it's not just about what it could power, but what unintended consequences a globally charged environment might unleash. Effects we might only truly grasp decades or even centuries later.
So, we've explored Tesla's incredible, maybe controversial, vision for the Wardenclyffe Tower as this gateway to global wireless power. My perspective really highlights the scientific ingenuity I see behind his designs and the potential for a truly world-changing, virtually free energy system. A system which I believe was regrettably thwarted, perhaps primarily by powerful commercial interests and the prevailing economic models of the time, rather than some fundamental technical failure.
And my perspective, while fully acknowledging Tesla's brilliance, emphasizes what I see as the significant scientific hurdles, the immense efficiency challenges, the practical deployment issues, and also the unaddressed environmental and health risks. These factors, I contend, made such a grand-scale system fundamentally flawed or, at the very least, profoundly premature for his era, regardless of the financial climate.
Right. While we clearly continue to hold different interpretations on the true reasons for Wardenclyffe's ultimate failure and the feasibility of Tesla's grandest designs, it is absolutely clear that Nikola Tesla pushed the boundaries of electrical engineering in ways very few others have ever dared. His work, without question, continues to inspire and provoke thought about alternative energy futures.
Indeed. Ultimately, the Wardenclyffe story isn't just about Tesla's genius or his financial struggles. It serves as a kind of timeless case study, doesn't it? It's about radical innovation grappling with the hard realities of physics, economics, and societal readiness. It really prompts us to ask, what truly defines feasible when we're weighing groundbreaking potential against practical constraints and potentially unforeseen consequences?
Thank you for listening to The Two Beans in a Pod. If you are interested in the book, please order it from the link below. And if you enjoyed this debate, please do hit the like button and subscribe to our show for more in-depth analyses like this. Your support helps us bring these debates to life.